Hello, grade 7. This is Mrs. Lopez. Today we are working on lesson 17, finding the area of the circle. Now, finding the area of the circle is different from finding circumference of the circle, and we will talk about that in just in a minute. But before, let's see what we can do to find the radius of the circle if we know the circumference. Let's think about it. We know the formula for the circumference is in terms of radius is 2 times the radius times the pi, right? And that is actually going to be very easy if you know the material from the topic 2 or 1 solving equations. So if you remember, let's just substitute all the numbers that we have here. The circumference of the circle is 37 and 68 inches. So that's what we are going to put instead of that C right here. 37 and 68 That equals 2 times R times 3.14 for the pi. Okay, now let's multiply what we can multiply. So 37 and 68 equals 2, and I can multiply that by 3 and 1 4. So that will be 6 and 28 R. Okay, now how do I find the R? And that I will do by multiplying by the reciprocal of 628, right? So if I multiply both sides of my equation by the reciprocal of 6 and 28 that'll be times 1 over 6.28 on one side, and on the other side 1 over 6.28. I will put 37 and 68 over 1, and what I will need to do is to divide 3768 by 628 to simplify that expression. And here we have 6 and 28 and 6 and 28 simplified with the result of 1, right? So 1R, or just R, equals, and now I can take my calculator or I can just use my long division. It's up to you. For me, it will be easier to show you here. So I'm clear that up. 37 and 68, I'm dividing by 6 and 28 and I get 6. Okay, so radius is 6, and in this case it's inches. 6 inches. Okay, that's how you find the radius if you know the circumference. Pretty easy. Determine the area of the rectangle below. Name 2 ways that can be used to find the area of the rectangle. Okay, going back into, I believe, 4th or 3rd grade. Okay, that's when you learned how to find area of the rectangle. This rectangle is made out of 4 units that make the height of your rectangle and 6 units that make the length of your rectangle. One way that probably you used in 1st grade is you counted all the squares inside of it, right? So if I have 6 right here, I will add another row of 6 and another row of 6 and another row of 6. So way 1, count the squares inside of the shape Okay. When you went to the 3rd or 4th grade, way 2, you learned that you can multiply side by side, or length by width, or length by height, to get the area of the shape. So way 2 is to find the area by multiplying length times width, right? And you will do 6 times 4 equals 24 centimeters squared, right? Okay, so that's how you learn how to use equations in the fourth grade. Let's look at number 3. Find the length of the rectangle if the area is 27 centimeters squared and the width is 3 centimeters. So if I have my rectangle and inside I have 27 centimeters squared, that's the area. The width of it is 3 centimeters. To find the length, I will call it x, right? I know that 3x would equal 27. So 3 was multiplied by some number to make 27, and that number is 9. But how do I find that x? I would multiply by the reciprocal of 3, right? Going back to the 7th grade, I'm multiplying by 1/3 both parts of my equation, and I'm simplifying 27 and 3, and that's how I get my 9. X equals 9, and that is centimeters. To find out whether I'm correct, I'm going to put 9 instead of my x right here. 9 times 3 is 27, and that is the checking the solution right here. Solution check. All right. So now that you remember all that information from the grades before, let's talk about the area of the circle. This is the exploratory challenge that you can do on your own by performing all of these operations. I'm going to just go through it and try to explain to the best of my ability so you can understand from the video. To find the formula for the area of the circle, cut the circle into 16 equal pieces. So here we have a circle and it's cut into 16 equal parts. Arrange the triangular wedges by alternating the triangle directions and sliding them together to make a parallelogram. Cut the triangle on the left side in half of the given line and slide the outside half of the triangle to the other end of the parallelogram in order to create an approximate rectangle. So what they did here is they took those slices of the circle and they put the bottom part here, the top part here. They slid them together and it became the parallelogram. Then what they did, they cut this little piece in half and put that other half to the other side. And that became a rectangle. Okay, so here we have half the circle. Here we have half the circle. And what this part is the length of each side here. So each of these is the radius of your circle. That is the radius of the circle. That is half of the circumference, isn't it? Because circumference of the circle is the outside of the circle. This is half of circumference. Half of circumference. The circumference is 2 times pi times radius, where the radiuses are. Therefore, half of the circumference is just pi times the radius, right? Because we will have to divide by half, by 2, or multiply by 1/2. If I multiply 2 pi r by 1/2, I would simplify 2 and 2, and that's how it becomes pi r, right? So this is half of the circumference, which is pi r, and this is radius, which is r. What is the area of the rectangle using the side lengths above? So this is pi r, this is r. I would find the area using these sides, right, of this rectangle. So that goes back to first problem here. How do I find the area of the rectangle? By multiplying the sides. So now I'm multiplying the sides of my rectangle, pi r times r, isn't it? Okay. Are the areas of this rectangle and the circle the same? Yes, because this rectangle is made out of, literally made out of this circle. So I find the area of the circle by finding the area of this rectangle. So yes, the rectangle is made out of the circle. Is made out of circle. If the area of the rectangular shape and the circle are the same, what is the area of the circle? The area of this circle is going to be exactly the same as the area of this rectangle. A equals pi times radius. Going back into our module 1, when I multiply a number by itself, that will give me the, sorry, it was module 2, that will give me the radius squared, wouldn't it? Something with an exponent on top shows me how many times the number is multiplied by itself, right? So I can write pi times radius, or to make it more efficient, I can write area of the circle equals pi times radius squared. And 2 will tell me how many times I need to multiply a radius by itself. That is different from circumference. If you remember, circumference can be found by multiplying 2 times r times pi. This one is pi times radius. Do not be confused with multiplying 2 by the radius. This is radius multiplied by itself, and we just proved it by doing all of this work. Example 1. Use the shaded square centimeter units to approximate the area of the circle. Each square in this picture is equivalent to 1 centimeter. What is the radius of this circle? If I'm looking from the center to the outside of my circle, I can count all of these squares. So I have 3, 6, 9, 10. So that is 10 centimeters. 10 centimeters. What would be quicker method for determining the area of the circle other than counting all of the squares in the entire circle? So one thing I will have to do, right? I can add all of these squares, and that will be super long. And most of us, I would say I would get confused at some point. I would get lost in counting all of them. That's why we are going to use the formula for the area of the circle, which is pi multiplied by radius squared, or pi times radius. Using the diagram, how many squares were used to cover 1/4 the circle? Okay, that's not it. Let's find, okay, so that would be a quicker method by using the formula. Okay, how many squares were used to cover 1/4 of the circle? Honestly, I don't even want to count them all. It seems too long and too complicated, so I'm going to just skip this question and find the area of the entire circle by using the formula. Area equals pi, which is 3.14, times, and we are multiplying radius, which is 10, by another radius, which is 10, right? Or I'll write it here, area times 3.14 times 10 squared, right? When I multiply by 10, all I need to do is to move my decimal point to the right once, and by 10 more to the right one more time. So it's like multiplying by 100, right? Moving my decimal point to the right um, 2 times. So that'll be 314, and now it will be centimeters squared since I'm multiplying centimeters by centimeters. Okay, let's look at example 2. A sprinkler rotates in a circular pattern and sprays water over a distance of 12 feet. What is the area of the circular region covered by the sprinkler? Express your answer to the nearest square root foot. Okay, we can draw a diagram to represent the problem. So we have a sprinkler that rotates in a circular pattern. So it goes up, 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 right, in making a circle. I'll draw a circle the best I can here. Okay. So that is the distance is going, right, around itself, making all of these points on our circular distance region. So the sprinkler rotates and sprays water over a distance of 12 feet. So from where the sprinkler is to until it stops sprinkling is 12 feet. That makes the radius of that circle. And we need to find the area that is being covered by the water. So right here, we need to find the area of the circle, right? What information is needed to solve the problem? Radius of the circle. Okay. To find, I think there is one more question that is missing in this problem is actually solve the problem, find the area. It's here, but there is no space provided for us to do it. So we'll do it right here. Area is pi times radius squared. And to do it, I'm multiplying 3 and 1400ths by 12 squared, which is 3 and 1400ths times 12 times 12. Okay, so again, I will take my calculator to make it easier and faster. And I'm going to multiply 3 and 1400ths by 12 and by 12 again. 452 and 1600ths. 452 and 1600ths. That is in feet squared. We want to approximate to the nearest square foot. Nearest square foot is in ones place. It's right here. Because the number to the right is 1, which is less than 5, I don't have to worry about the decimal places. So in my answer, the area covered by the sprinkler is 452 feet squared. Example 3. Ernie is making a circular table out of a square piece of wood. The radius of the circle he's cutting is 3 feet. So right away, I'm underlining radius 3 feet. How much waste will he have for this project? Express your answer to the nearest square foot. So draw a diagram to represent the problem. What does the distance of 3 feet represent in this problem? Okay, so we have a square, a square piece of wood, and we're cutting the circular table out of that piece of wood. Okay. Radius of the circle he is cutting is 3 feet. So it's right here. That's the radius. We want to find how much waste is being left. So after we cut the table, we want to see how much is this shaded part, how much is left out. We want to find the shaded area. The distance of 3 feet, what does it represent in this problem? That is the radius, or it's also half the side of the square, isn't it? We can say a radius of the table and half the side of the square of the square. So to find the full side of the square, I will need to multiply it by 2, right? Or what I want to do is to find the area of that circle. And another thing that I want to do is to find the area of my square. When I find both areas, I will be able to take away that area of the circle to find what is left. Okay, so what information is needed to solve the problem? Area of the circle and area of the square. Area of the circle and area of the square. Okay, what information do we need to determine the area of the square and the circle? We need the radius uh, of the circle, right? Radius of the circle. Okay. How will we determine the waste? We'll do it later. So let's well, I just talked about it earlier. We will take the area of the square and subtract the area of the circle to find the missing parts. So subtract area of the circle from the area of the square. Okay, so let's do it here on the side so you can see better. How do I find area of the circle? Area of the circle is pi times radius squared. So it will be 3.14 times that 3 and times the 3 again, right? On my calculator, I'm doing 3.14 times 3 times 3 again. That is 28 and 26 hundredths. And here we have feet squared. To find the area of the square, I need the diameter of the circle, don't I? Diameter of the circle. Because diameter of the circle is the side of the square. Diameter of the circle is going to be twice the radius of the circle, which is 3 times 2, right? 3 plus 3 is 6. 6 feet. Okay, So area of the square can be found by multiplying 6 by 6, 36 feet squared. Now what I have left is to subtract these two numbers. 36 minus 28 and 26 hundredths. Okay, so here I will have 4, 9 minus 2 is 7, 16 minus 8 is 8, and that's it. 8 and 74 hundredths. But now we need to round to the nearest square foot. So we look at this number. This is our nearest square foot. 7 is more than 5. That makes this number a 9. So the waist, the area of the waist is 9 feet squared. Okay. Exercise 4. A circle has a radius of 2 centimeters. Find the exact area of the circular region. When we are talking about exact area, we are not using approximations. We are using pi as a letter. Pi as a letter is the most exact representation you can have. Okay, so the area is pi times radius squared. The radius is 2 centimeters. So you will have pi times 2 times 2. That is 4 pi, isn't it? We will leave it as that. 4 pi centimeters squared. That is going to be our answer. That is the most exact answer you can have, because pi is a number that never ends, and any way we use the calculator or use 3.14 or 22 over 7, that is going to be an approximate answer. Okay, just like here, we are going to approximate the area using 3 and 1400 to approximate the pi. Here, this is the exact answer. Now, the approximate answer is going to be the same thing, the same formula for pi, but I'm going to actually use 3.14 for pi. So 4 times 3.14, and 4 times 3.14 is 12 and 56 hundredths centimeters squared. That's the approximate answer. Next one. A circle has a radius of 7 centimeters. Find the exact area of the circular region. That means in terms of pi. In terms of pi. So what I'm going to do, area is pi times radius squared, which means pi times 7 times 7. That will be area equals 49 pi centimeters squared. This is all for the exact answer. For the approximate answer, we are going to continue multiplication. We are going to multiply 49 by 22 sevenths. Okay, area equals 49 times 22 sevenths. 49 and 7 can get simplified. 49 can be simplified to 7. 7 will be simplified to 1. And that will be 7 times 22. 7 times 22 is 154. And that is going to be centimeters squared. Okay. What is the circumference of the circle? Now we are going back to our formula for circumference. Circumference equals 2 times the radius times pi, right? So instead of using 7 times 7, we are going to use 7 times 2 times 3.14. Okay, and that is going to be 14 times 3.14. 14 times 3.14 is 43 and 96 hundredths centimeters without being squared, right? Because circumference is just the distance around the circle. See the difference in our answers? That is a big difference. That's why you shouldn't ever be using the same formula to find both circumference and area. Okay. Last one, number 6. Joanne determined that the area of the circle below is 400 pi centimeters squared. Okay, 400 pi is the area inside. Melinda says that Joanne's solution is incorrect. She believes that the area is 100 pi centimeters squared. Who is correct and why? Okay, so what do I see? First of all, I see a circle with the diameter of 20 centimeters. We are given the diameter of 20 centimeters. Okay, so if I see diameter that is 20 centimeters, then I can find the area by multiplying pi by radius squared. I don't have the radius, but I know the radius is half the diameter, which is 10. Radius equals 10 centimeters, right? So that will be pi, since it says in terms of pi, that's all I'm doing. Pi times 10 times 10. That makes it 100 pi centimeters squared. Okay, that means that Melinda is correct, right? I can see how Joanne would be correct as well. If Joanne sees this circle and since that the only radius is 20 centimeters, because 20 centimeters kind of written down in the radius part, then she would multiply 20 by 20, which is 400 pi centimeters squared. So Joanne might have seen that 20 is the radius, right? Not the diameter. Okay, that's the only difference. If you see a problem like this, and if you just pick the answer, then that will be wrong, because that's how I can see that that's how I need to see your work to be able to say whether or not you're correct. If you see the radius, which is 20, for me, if you just write the answer, you got it wrong, because you never explained to me that you see the radius of 20. I see the diameter of 20, right? That's why the showing work is so important. That is the end of lesson 17. If you have any questions, please message me. If not, please do your homework and I will talk to you in the next lesson.